So let me show you the Enterprise Inspector. This is our environment. Also, I'd like to point out that the practices and the steps which I will show you today are relevant also for the version 1.2, 1.3, 1.4. So today it's not going to be about presenting the new features in 1.4. It's more about the universal steps during optimization and during investigation. So for our example, in our demo environment, we are using the version 1.3. So as you can see here directly from the dashboard, there are some few charts that can point you in the right direction where something is wrong. For example, this chart, if the environment was running for a longer time, you would see a chart of alarms generated per day. And it should be relatively even. In our case, well, basically the environment was off and we reverted it and started only for this session. So you cannot see the alarms at the moment. However, if it was running for a longer time, you would expect relatively even level of alarms. If there was some kind of spike, if there was a peak in the chart, that can be something like when a new computer was added to the network, right? Or maybe there are some scripts, some testing scripts or security scripts, which are run on a regular basis by the IT department, some kind of testing. You would also see that as a kind of spike in the alarms there. Other than that, if you see some kind of spike which you cannot account for, which you don't know what the reason was, that can be a little bit suspicious, and you can focus on that time frame and investigate these alarms a little bit more. That can be a little suspicious. I hope you all know what alarms are. Basically, the system of ESET Enterprise Inspector is based on the endpoints on the client computers collecting a lot of raw events, everything that is happening in the system. Then they send these events to the enterprise server where they are processed. And when I say processed, I mean that they are basically compared to the set of rules which define what we are looking for in the system or what kind of behavior we consider to be suspicious. And when some events match the conditions in the rule, an alarm is triggered. And you don't have to look at the list of thousands and millions of events. You just get notified if some of them, for example, you can see the instances, you can see the example here, match these conditions, you see only the alarms here. And they of course have different severity. Basically, we distinguish three severities. Informational alarms, they are perhaps not as serious, they are worth checking for your information. And then the more serious ones, which are warnings and threats, these three levels. So as I mentioned, these warnings and threats are perhaps worth your attention more. So that's just the first view, and you get different views over here. We've got some training videos which will guide you through all of these and their significance and what to be on the watch out. So I will not go through that today. However, I would like to point out that when you install EEI or when you deploy EEI in your environment for the first time, you can expect that there would be also some kind of noise or extra alarms that are false positives that needs to be filtered out somehow. This is natural because we have to keep in mind that EEI was developed as a universal tool. However, each environment really is different. Each company is different, and the system, the network, it cannot be it cannot come out of the box optimized for each environment. So definitely you or the administrator, the security admin in the company knows the environment the best, knows its specifics, knows what's okay, what is not okay. So there are some steps which needs to be done by the person responsible to make the environment optimized. And then all the alarms should be relevant. What we can see directly is that there is a kind of disproportion in the number between the kinds of alarms. There are some instances of alarms where suspicious DLLs were loaded or created. Then there are some alarms connected to some scripts being interpreted, WScript as the Windows script interpreter. So perhaps some JavaScript was run. But we see really big number of alarms compared to the others. And this is a small environment. So this is relatively a big number of MSHDA executing a process, alarms connected to this. That means the Microsoft HTML application, the interpreter for HDA applications. That could mean that, well, of course, at this point, we don't know if it's something malicious or not, but it could be that this is a sign of something not optimized in the environment. A lot of alarms of the same kind, much bigger number than the others. We can check it out if our suspicions are right and they come from the same group of computers or from the same computer. It can be that all this noise is coming from one computer when there is perhaps, it can be an internal tool, it can be some less popular application. So we will have to investigate, and definitely we don't want some noisy computer or some application or process which is creating a lot of alarms unnecessarily, because more important things can get lost or can get overlooked as the result. So still in the dashboard, in the section computers, I can see also the numbers of alarms triggered on each computer, sorted by each computer. We can take a look at the whole number of unresolved alarms and the unique unresolved alarms. Well, both of these are relevant. Basically, now we can see that there is a big number of unresolved alarms, but very probably many of them of the same kind on client 11 developer's computer. So very probably this might be some internal application causing this. However, when you are monitoring the environment and you're looking for, let's say, advanced persistent threats or targeted attacks especially, also the unique unresolved alarms view can be very important, because it's a typical feature of targeted attacks that they try multiple ways of getting into the computer. They would be probably suspicious in more than just one way, as they are really crafted, tailored to one organization. So probably it wouldn't give up after trying just one vector or one way and it didn't succeed. And probably the attack would have more stages. So seeing a spike or bigger number of new unique alarms on one computer can be alarming, and it's worth checking definitely. So at this point, we know that there were a lot of alarms of the same kind. Also, we see that there is very big number compared to the others of alarms on this computer. So from the perspective of optimization, definitely we need to check out client 11 computer. That probably would be the most interesting. And this is the computer details view, when you can see a lot of information about the network status, system, etc., etc. But what I'm interested in is the tab with alarms. This will show the alarms on client 11. And we will check out what these alarms are. And you can see also by scrolling that really the majority of them are of the same kind. More practical than scrolling is using some kind of grouping. So in version 1.3, I've got this drop-down menu when I can group the alarms based on the rule that's triggered them, based on the uniqueness. And that's a good idea right now, because we want to make sure that there is the same application or same process that is triggering this kind of alarm. And we can see that this is the case, that all 222 alarms MSHDA executed a process come from this computer and are being triggered by the same situation, basically. So let's check them out. Typically, in the alarms view, the most frequent way of sorting or most frequent criteria for sorting are the time periods. So by default, it's occurred time. So we see the most recent alarms. This is an environment which was created a year ago and we revert it every time. That's why we see that these alarms are 1 year old. And it doesn't tell me much about the time sequence. So what you can do is actually click in the line and use absolute time view, which for most of the time, or if you're doing the certification and you need to investigate some specific time process, and definitely in real life when you know what is the time frame, what you're interested in. So I recommend using absolute time. Then when we expand, we can check out that they actually happened in very, very short sequences, one after another. So it seems to be some consecutive action on the same date, multiple alarms within a couple of seconds on one another. So we can pick any of these alarms at random and it will tell us something also about the others. The source seems to be the same. And I will do that investigation a little bit in a while. But before I do that, I just want to show you that if you just scroll to the right, and you can customize these columns as you like, you can add extra columns, also organize them to the left to the right as you need. Also, you don't need to go deeper into the alarms. You can see a lot of information directly over here. You can see which application actually called or caused the alarm. In this case, it was the script interpreter, obviously. And you can see also what command it was. And it seems that from this location, ESET functionality tester temporary file, it was some Visual Basic script or wait command in Visual Basic and with various parameter of milliseconds that it was waiting, all triggered by client 11. Client 11 user was logged in. So it seems that in this case, the course of action would be to ask the developer, the owner of the account client 11, if they know about this activity. And first, we'll just find out what executable we should ask them about when we, for example, call them. So I clicked on one of the alarms. As I said, it's representative also of the others. They seem to be connected. And I will just briefly introduce you to this alarm details view. Very, very important. You will spend a lot of time over here during your work with EI. Over here on the right side, this is the process tree view. And you can see which process was started by what parent process. And you can see also the standard startup over here, like WinLogon user init that started explorer.exe, that is basically the user. And the user started something called ESET functionality tester.exe, some executable called ESET functionality tester. And that's the one that actually called for Microsoft HTML applications interpreter, which called the W script probably to interpret some JavaScript operations or JavaScript commands. So basically, when we go up the tree, when we go a little bit up the tree, yes, we can see that in one instance or one session of running, there were multiple alarms. This yellow color represents that an alarm was triggered by this process. This is the process ID. So many alarms were actually triggered by one run of this application. So this is actually the executable I should be investigating and I should be asking the developer about. I should ask the user of client 11 in our fictional company What is ESET functionality tester? I can check out also where it is located. Directly on the desktop in ESET tools. So at this point, I would probably call the guy, client 11, and ask about ESET functionality tester application that he or she uses, located in ESET tools on desktop, that it's creating some noise in our EEI system because it's calling for some JavaScript, and it is an application which is actually not signed, it's not popular, it's not seen much elsewhere in the world. So this is the reason why the alarm is triggered. So I would ask them if this is a safe application, if it's something what they developed, and if it's okay that it is running, if they know about it. Because it's something what is not official, right? No signature and lower popularity. And let's say that in our case, really we find out that it is okay. It is basically some application that they are using internally. We can switch to client 11 and we can check it out directly. I'll try to remember their password. Right. So this is the client 11 developer's computer, and it said desktop ESET tools. And yes, here we can see the ESET functionality tester application. So this is the application that is causing the trouble. And as I mentioned, let's imagine this is some kind of internal application that's why it's not signed. It's just used internally for checking if there's connection to, for example, repository servers, Lightgrid servers, etc. However, running these kind of tests, because it's not signed and not popular, triggers some alarms in our EEI. Well, the question is, from optimization perspective, what we can do about it. The thing is, when you view the alarms and the number has grown, when you view the alarms, you have also some kind of choice to mark them as resolved. So we have this client 11 computer, and I'll just send the wake up call to receive the most recent events. When I go to the alarms, and there's also the option to select all of them and mark them as resolved, and they would basically disappear from the EI view unless this button resolved is checked. But if we then run the tests again, if the developer and client 11 computer runs the tests again, we would get the same number of alarms again and again. So this is not a permanent solution. Also, some people might be tempted to disable this rule, MSHC executed process, to switch it off or disable it. However, we definitely do not recommend this. This would create a big security hole, as any HTA application that even might be malicious would not be reported by this rule. So that's also not a good way. There's the middle way, and that's what we recommend doing, and it's creating an exclusion. To every rule, you can have some exclusions. You can specify which processes, which users, which computers are not triggering the alarm, even if they are doing the activity which is defined in the rule. So let's check it out. I will show you what it looks like. I can call it ESET functionality tester exclusion, and basically criteria is the part that we are interested in. So you can define the criteria for a process or its parent process or any of the ancestor processes that says that if the activity which normally triggers the alarm is done by this kind of process, it will not trigger the alarm. So it gives you also some suggestion, like if the name of the process that is triggering the alarm is wscript exe, which was true for all of them, and you have the choice also to include the command line, right? If the command lines interpreted are one of those, and it's the legitimate W script, which is signed by Microsoft with a valid signature on, for example, client 11's computer, then this activity will not trigger the process. One change I would make is not only on client 11's computer, I would include the whole development group as it is structured in ESMC and also EEI. We are using the same structure, so I would define the whole static group development. However, using the command line, it's relatively safe because it's kind of specific in this case with the whole path, but not including it, it would again create a big security hole. We don't want that. However, it's too specific with also the numbers of milliseconds defined. And if there's a new version, some kind of modification of this tool, when let's say it waits for 50 milliseconds, then we would have these alarms once again. We don't want that as well. So maybe this is the right time to define the criteria, not for the current process, but maybe for the parent process. And we've seen it in the process tree, if you remember, that it was always MSHTA, the Microsoft HTML application interpreter, that triggered or that called for the W script that triggered the alarm. So maybe we can take a look at some criteria we can define for MSHTA. And this will make sense because in all the cases, it was basically ESET functionality tester HTA application that called for the Visual Basic script. And this configuration just might work. And it's, I believe, safe enough that basically only in this situation when it is ESET functionality tester HTML application that is calling or being interpreted, even though it is not popular elsewhere in the world and the executable that is triggering it, it's not signed. Using this exclusion, it will not trigger the alarms that clutter our enterprise inspector. So you can definitely check out the section rules, because as I mentioned, exclusions are made or created specifically to exclude the activity from one rule. It shouldn't be something universal that now, because of this activity, no alarm will be executed by this application. That's not safe. So I will just check out that only this one relevant rule is selected, and it's like that. So this MSHTA executed process, that's the only rule we want to exclude based on this. And this is the summary. Also in human language, explaining what this exclusion will do. And I believe that's what we want. So we have created ESET functionality tester exclusion, which is now enabled and should be working. So let's check out client 11 with the alarms. I believe now it's the good time that I can select the alarms and mark them as resolved. They will now disappear. You can revisit them if you use this filter, obviously. And I can very briefly check it by running the tests on client 11, let's say connectivity to LiveGrid. Okay, so it tried to connect somewhere. We can run another test. So there are some network connections. And after a while, we can switch back to our environment, to our EI console. And notice that we would not see the alarms appear here immediately anyway. You probably know, if you've done the deployment part, that there is a connection interval between the EI agent that is running on the client computer and the EI server, that is the central processing unit. And the interval, it's by default 7 minutes or some number of events that is reached, and then the connection is initiated from the agent side, that the agent sends all these events, all these raw events for processing to the server. Because this is not a preventive system, this is category of software which is called EDR, endpoint detection and response. Basically, it's not meant to be a prevention system. That's where we have our endpoints, endpoint antivirus, endpoint security, etc. So that's why the connection is not immediate in all cases. This is basically more for the gray areas, for the situation when there is the interaction of the administrator necessary. So that's why this connection interval, we can say it's okay. But if you're investigating something that is happening in real time, like we are now, you have the option to trigger sending of the events immediately. And that is by sending the wake-up call. So don't forget about that. Also, when you will have not enough time and you will be under some time pressure, for example, during the certification. So when you trigger some activity on the client computer and want to investigate it, before you go into the details of the computer and alarms, always send the wake-up call. After sending the wake-up call, the agent reports back. And after a couple of seconds, the events are processed. And if there are some new alarms, at this time, they would appear here. But in our situation, in our case, because the exclusion seems to be working, we have no new alarms. Okay, so that's basically very, very simplified example of how the optimization using the exclusions work. So first you identify what rule on which computer is triggering the alarms unnecessarily. You definitely investigate if it's really unnecessarily, if this should be excluded, and if so, you try to create the exclusion as specific as possible. Of course, you don't want the problem to return after 1 week when something small changes, but you don't want to make it too general, so you don't create a security hole or some blind spot in the system. Great. So much about exclusions. If anything is unclear, please let me know in the questions panel. I can try to return to some of these things. Also, I would mention that when you create an exclusion and this graphical interface is not enough, and you cannot define exactly what you wanted, you can use the advanced editor, which uses an XML structure, very, very similar or basically identical to the structure of rules, which if you are using EI, you will need to be familiar with. And using this, you can also create an advanced level of exclusion, which really, really specifies in very big details what you want to exclude. Okay, I see no questions at this point. So I believe we can move on to another thing I wanted to show you from the environment before we go through the scenarios and case studies that we have prepared for you. And that is based on the fact that when you're, for example, working with EI console for the first few times, it's confusing like where to start. And some people have the tendency, maybe when they are somewhere on, they go to the details of the computer and look at the events. But I definitely do not recommend doing this. I understand why people have the feeling that this is the biggest amount of data. These are basically the raw events that were sent for processing. But this is a waste of time checking out step by step what happened at which millisecond. We have the set of rules and set of very good filtering to basically point you to what is important. So it's very, very rarely that you will check out second by second what happened on each client computer. So don't make that mistake going to the events, because you will just lose a lot of time over here. So rather try to find some more general information, and definitely alarms is more suitable. And speaking about filtering, I will show you maybe just one example of how we can use filters, because filters are basically very, very similar in all views that we have in EI. Of course, the categories of the filters are different based on which category we are in over here in the main menu. So I will demonstrate it with executables maybe, because in the same way, like there are really thousands of events on each computer, there are definitely thousands of executables in every environment. This is a really small environment that we are using. We've got 5 computers, but still you can see that there are over 4,000 of executables. And if we include DLLs, it's even a bigger number. And this is not possible to investigate manually. Many of them will have low popularity because they are just generated. For example, we see that there are some torrent executables, generic ones. And yeah, there are too many of them, which, okay, visually they seem suspicious, but it's not possible to investigate by hand. This is the situation when powerful filtering is really necessary. And over time, you will create your own filters, create your own normal, what is okay and what should draw your attention. However, we have prepared also some kind of predefined filters called risk levels. I will just walk you through them to give you some inspiration of what you can use in your filters. So for example, using the risk level number 1 takes down the number of executables to really much smaller proportion, only some suspicious ones based on the popularity. Popularity basically means on how many other computers we have seen this executable elsewhere in the world. This is based on the data from the LiveGrid, our online reputation system. So we have information from millions of computers around the world. And if this application was seen on, let's say, 10 million computers elsewhere, it's very, very probably some kind of software that is legitimate. Of course, it's not a guarantee, right? But it's very probably some part of the system or some legitimate software. However, if it's something that is doing something suspicious in the computer, and also it wasn't seen nearly anywhere else in the world, it can be a sign that this is something targeted at your company, that it's some kind of attack that tries to evade detection, and it wasn't seen anywhere else, and that's why it's not detected. Because standardly, some malware that is popular, very, very probably it would be detected by the endpoint solution. So you can use the slider over here. We can see that at the moment, it's viewing only the executables that are in the system, and we didn't see them on more than 1,000 computers globally. Then risk level number 2 adds one more criteria, which is reputation. Also reputation based on our cloud reputation system, LiveGrid, when we store this data globally. If something is detected somewhere on the other end of the globe, elsewhere in the world, all the other endpoints will know about this detection based on this LiveGrid reputation system. And there are different levels as well, from something that is clearly malicious and we know about it, to suspicious things. gray areas such as potentially unwanted applications, maybe some kind of adware, advertising software, some bulk installers, etc., up to good reputation and safe applications. So you can use the slider. Then again, we can add the risk level 3, which takes into account signature as well, whether or not the executable is signed by a valid or a trusted authority. So we are using 5. Of course, some of them are self-explanatory, like unknown signature if the signature is not valid or if it's not signed at all. But then there is also valid and trusted, which is confusing for some people. Basically, trusted is more than valid. Valid means that, yes, the executable is signed by some certification authority. However, we have seen cases that a certification authority was somehow misused, and cases of even malware being signed by some stolen certification authority. Such certification authority would then go on our blacklist, and that's why trusted basically some kind of our internal whitelist of certificates or certification authorities that we don't know were, let's say, misused or somehow mishandled for such nefarious purposes. So that's why the choice is up to you, depending on the situation, but trusted is basically one step more than valid. So this signature type, less than none, basically would check out all the signatures that are, or all the executables that are not actually signed. So still we have 48. It would be perhaps too much to go one by one at this point. So we can check out what risk level 4 brings. And in this case, it adds this criterion that the executable was actually started at least once on some of the computers. So that's a little more pressing, that's a little more urgent if we know that some suspicious executable is not only there, but it has been executed. So that's really the situation when we need to take a look at it, if it's legitimate or not. And I will not go deeply into these, like checking out the executable, checking out the different elements, when it is considered suspicious, when not. This is really up to your skills. You're all technical people. I will not go into these basics. And also, it's part of our video course when we demonstrate a little bit, when we take a look at, for example, service host, SVC host, which we directly see is not legitimate. It's not the genuine SVC host from Windows because of the popularity, right? It's really low, and legitimate SVC host that is running as part of every Windows system must be seen at least on millions of computers, right? HTML server, not popular, but it might be some slightly less popular application which is legitimate. But these things need to be investigated. Okay, so that's basically the system of filtering. I demonstrated on executables, but definitely you can do it in all the other areas as well when it is relevant, with scripts, with the computer alarms view, etc.